Okay. All right. Well, thank you for inviting me to be here. My name's Matthew Paradise. I'm in my home state, which is Indiana. Grew up here, lived here for a while. I did play some sports in college and a little bit of pro. So I went to Xavier in Cincinnati for 4 years, and then played some soccer in Florida. But other than that, I've been in Indiana most of my life.
Where did you grow up at in Indiana, can I ask you?
So well, if you're from Indiana, the Meridian Kessler area, Butler Tarkington area. So that's kind of a little bit north of downtown.
Okay, yeah. I am from Indiana, actually. Grew up, born and raised
Okay.
up in Northwest Indiana, so
Okay. Kind of the region or not as far north.
up in Chicagoland area around Michigan City, Maryville, that area.
Yeah. Okay. I'm familiar with that area. Um, yeah, so I'm in Carmel right now, which is North Indianapolis. But I've always been into technology, even when I was little. So this is going to date me. We had an Apple computer when I was younger, and kind of grew up with just basic coding. I would get bored. We didn't have a lot of money, so we spent a lot of money on the computer, and it came with this little programming booklet, and I would program and do stuff like that. I actually had an internship in 8th grade, if you can imagine that, and learned on these old reel-to-reel type computers. Um, yeah, and then did information systems at Xavier. And even though I played sports, I kind of came to a point where I had to make the decision. I was not getting paid a lot. I was playing professional indoor soccer in Florida, and I got injured. And when you get injured, you don't get paid. When you're I was only making like a couple $100, a week. They paid for your lodging and your food and stuff. And I had to make a decision: was I going to actually get a job, or was I going to pursue that career? And an IT place in Brownsburg, Indiana, called me, and I've been in IT and data ever since. So here we are. Now that brings me to my latest uh, project or role, and that was with the state of Indiana. So I am a senior consultant, um, technically INDOT senior manager, but also a liaison to the uh, research grant funded project we have with Purdue University. But I'll get into that a little bit later. All right. So the few things I'm going to talk about here, I'm going to give, I've talked about this with a lot of different groups. And depending on where everybody was, I gave this talk to some developers a couple weeks ago, and so I skipped over this next part. But just because I'm not sure where everybody stands, there is a little bit of an overview about AI in general. I'll just talk about that pretty briefly. But then we're going to hop into some of the cool stuff that that I've done at INDOT and what we're doing, and some future prospects, along with the benefits, challenges, and ethical challenges and implications of using AI, which I'm sure a lot of you have thought about. So if you've done any research on AI, then there's actually quite a few different types of AI, and this is just basic. I think technically there's 7 types. The majority of items after this, most of us probably aren't going to get into, but I thought I'd talk about just some of the things that we're going to go over today. And so machine learning, a lot of us probably know what that is. I have it up here on the screen. It's where you're going to basically learn from data, and the system's going to learn from it, and it's going to adapt. The deep learning is where you're going to take that data and learn even more. Again, this is super high level. LLMs is another term that we're going to be talking about. You probably all know that it's a large language model. And generative AI is the AI that pretty much everyone here has probably used. Even if you haven't created anything with an AI studio, you've probably used ChatGPT, Copilot, or Gemini. Yeah, and that's where you combine the LLMs with the generative AI piece. Now, there is a new thing. I added another slide because the big talk now, of course, is agentic. I'm not going to go into discriminative because that's isn't going to apply to what we were doing. But I did add this slide because people have asked me questions about this, and it is kind of a big deal, especially now that most types of software are allowing you to add this particular layer. So generative AI is where you create something new from scratch, where it's text or images. The agentic layer is where you could actually have it perform things a human being would typically do, and you give it the autonomy to make those decisions. So I'm not going to be talking about those because we didn't use those. We did just get a license for Agent Space, which is Google's agentic tool, but haven't done any projects with it. And I apologize if you knew all that stuff, but I thought I would go over it but we're going to talk about the first two pieces because the projects that I did for the state of Indiana really are going to center around the deep learning or the machine learning and the generative AI. Now, this one is a really cool project. This very first project was a document creation project, and it started out as just an executive order from our governor. They had 30 days to come up with documentation. Every department in the state of Indiana had to do this. You had to follow this executive order and essentially justify what you did, what your area did, what bylaws, statutes, etc. you were following as guidelines, and you had to come up with this long list of things. You had to prove what you're doing by using documentation provided by your area. So in my area in INDOT, that presented a really big problem because we had hundreds and hundreds and hundreds of documents. INDOT in the state of Indiana is the second largest department for the state of Indiana, and we have over 8,500 employees in lots of different areas. Construction, we manage airports. I mean, people think of just road and transportation, but there's just all these different facets. We have, drones that we use and just all kinds of things. So in order to come up with this document in 30 days, it's going to be really, really difficult. So we had the idea, okay, what if we try to use AI to do this? All right, the mandate. I kind of talked a little bit about it. Hopefully you can read what's on the screen here, but we had to map all of these statutory responsibilities to their core purposes, and all the data was just scattered. It could have been in SharePoint, it could have been on a website, it could have been, public facing, obviously. It could have been on some OneDrive or something somewhere. So this was going to be it was a really daunting task. But here's the cool thing, and I've worked in private sector for a while, but in public sector, you don't find this too frequently. But we were very lucky that our chief of staff, our chief legal, who actually is the head of the INDOT IT department, was very AI focused and said, "Hey, let's get this done." I feel like, and maybe you may or may not have felt the same in your areas that you're at if you're from public sector. There's a lot of fear surrounding it, and rightfully so, because there's a lot of public data that lots of public sector areas hold. And so using AI that gets a hold of that data, there's a lot of concern. It might be heading to the cloud. Where's the cloud? Where's it going to go? Who's going to have it? And specifically for us, making decisions, there's another mandate from the governor that no AI can be used if it's going to directly make decisions that affect people, things like that. So there's a lot of fear around it, but Allison Grand, who I'll mention in later, she came to me and said, "Hey, can we use AI to do this? And can we do it ethically? Can we make sure that the data is secure and stored locally?" And the answer was yes. We already had a test version of Google Cloud Platform, which we were lucky to have because of the joint program with Purdue. And so we were able to pop these documents in there, and I'll explain a little bit more about what we did in the next slide. So this could be just one area where there's documents, but if you look it's not a very good picture. Each one of these you can click into. Some of these you can click into, and there's even more documents and more documents and more documents. So, and you can't just go to one person and say, "Hey, can you create this part of the document and do it yourself?" And then, "Hey, can you do this?" And I mean, the whole idea, you get the point here, it is going to be really, really difficult. So what we did is we got leadership to buy in. Um, we use Google Cloud Platform, and if you're using Google now, you probably know Vertex is the AI studio that you would use if you're going to be developing an AI. And inside an AI studio, it's a lot more robust than just using chat. So you can, with a chat like chat GPT, you can do a few different things, but you can't ground your model. You can't create, retrieval augmented system where you only allow it to look at the documents that you have, you know, locally. I don't even know if you can chat GPT, you can even give it the ability to look at documents locally. We chose Gemini, and we're off and running. Um, Here's a list of some of the stuff we had to do, and it wasn't as simple. People think, oh, AI can do all this. It's great. It is. It's very powerful. But like I said, we had to use the AI Studio, but we also had to use some Python as well, because AI is really good at getting you close to what you need. You can tell it what to create, and it'll create something close, but for what we needed to get done, we really needed to, we were going to have to leverage some actual engineers and developers. Um, so in this process, what we had to do is we needed to get all the documents in one place. We used Python to actually pull the documents from websites that where we knew they were, because you can imagine trying to do that manually, still a lot of time to have somebody click and download. So that is something we did that wasn't 100% AI, but it was something that we had developers that were able to do that. Put them all in one location. Okay, so they're stored locally. Um, then we had to clean the data and make sure there wasn't too much redundant data, et cetera. So that took a little bit of time. Um, so our RAG pipeline included all the documents that we could pull from all the areas of INDOT into this one repository. And from there, if you don't know what a RAG is, it's one way of grounding a model where you only allow the AI to search documents. Search, it could be documents, it could be pictures, it could be anything. Search through the items that you want it to by putting it one particular area or only pointing it to one particular area. And that is one thing that we did, where after we did this, we were going to get a slap on the wrist, but we did follow all of the different steps to keep all of the data secure um, and local. Let's see here. We had some snippets. I don't really know what that part means, but it's funny because I wrote this. Let's see here. Yep, all of our model responses were based on INDOT's internal documents, and it was great. So we started out doing this with just some INDOT stuff. We didn't have any public internet data. It was all on our internal facing site. From there, we were able to create this document successfully, and it only took about 3 days maybe to get a very accurate uh, document that adhered to everything that was in the executive order, and it was great. So that was for one small area, and then we moved on to construction, which was our biggest area, and we ran this model, and we got 98% accurate on the next area, and we just kept going on down the line for INDOT. And the big thing that's really important to do is you can't rely just on AI to get it done and think that it looks right, so it is done. Because one of the other things in my slides previously, I talked about like this, like knowledge of each area was kind of extensive. So for each document we created, we had a human in the loop. We had a subject matter expert that combed through the document when it was done to look and figure out what was right, what was wrong. And then from there, we can tell Gemini what was right, what was wrong. And even in one instance, this is really cool. The tone was a little too conversational. And we didn't think about that in the the first couple iterations, and it kind of was. And because it's a language model and it's got natural language processing, you've probably noticed that every time you put a prompt in any of these GPTs or any of these chats, it comes back and it acts like it's talking to you. Well, a lot of times it's gonna, even if it gives you a template or a document in response, it could sometimes be a little too informal. So that was the thing, but we were able to tell it, hey, this is for this, and specifically said the prompt, this is a legal document, etc. And man, it fixed it really quickly. Now I know I hope I'm not rambling too much, but my background has been, from full stack development to data to this. And one thing I love about AI is if you're not paying for it, like I wasn't, you can try a lot of different things quickly and figure out if they work. Whereas when you're developing, I don't know how many of you come from the development background, but when things break, sometimes you get an error message, sometimes you don't. You have to recompile, and it's like trial and error, but you may not know what's wrong. And it's just this really, really rough iterative process. I remember times where it came down to like a misplaced semicolon, which, AI now can help with that. But still, with this, we were able to keep running this model and then keep fine tuning it and fine tuning it and fine tuning it, and until we got to what we needed. And as you can see here, 98% of it was accurate on the first go round once we got to probably day 4. And the little fixes were pretty quick to be done by the department heads. Saved 360 hours of manual labor because of all the areas that would have had to do this. We did it essentially in a week, maybe just a little bit longer. Um, yeah. And that allowed our staff to actually focus on what they needed to be doing instead of being like, hey, we got this mandate. You got 30 days to do it. Drop what you're doing and get it done. Um, you can see down here, largest agency to submit the efficiency report on time. And some of them didn't get it done on time, and they've since used our template as the standardized template for all the other departments. So it's a really big win, and it was amazing to work on, and it was crazy to see how quickly we were able to get this done. So, and then specifically for that one, if you want, I think I can send anyone. I actually wrote up a white paper on it, and it got picked up by Google. So they did a little article on Google's website about this really cool project. It's a little more succinct, and it's pretty cool. But we can send you the link to that if you want to read the article, or if you want to read the white paper too. I've got that as well. The next one, okay, this is one that did not have to deal with just documents. Uh, if you have used AI, and even in the chat world and like ChatGPT or Copilot, you probably figured out that if you ask it to do something that's just text based, it's pretty quick and it can figure it out, in a really short amount of time. But if you have it do anything that it's image related, then the time starts to kick up. And another thing I talked about when I said, it's fun to use when you're not paying for it. A lot of people don't realize is it's all when you pay for any type of studio or any type of AI, you're mainly paying for the compute power and the processing power. And anything that takes a lot amount, longer amount of time, it's because it's processing, and every second is money. And it's pretty, it's relatively cheap. But if you're doing something millions of times and it's taking, a few seconds each time, the cost can mount up. So this particular project was one where we were lucky enough that Google gave us credits to execute our pilot. So this was a high processing power intensive project, but we got to pilot it and test it out. So the main goal of this project, let me see what's on the next slide, was to inventory all the signs along 2 particular highways. So if you're from Indiana, you probably know where I-65 and I-70 are. They cross the middle of the state, essentially right in the middle of Indianapolis, right here. And we have this issue. We have a department that deals with signs, and if they're in the right position, if they're labeled correctly, if they're missing, etc. How we do it now is you have to either get a call where someone says it's gone, or you have to send somebody so often to go look and prove that the signs are there. And take pictures. And the reason why this is kind of a big deal is because some of the signs are critical. Like you can imagine, like no passing signs, speed limit signs, things where if they don't exist, there could be a wreck or there could be some kind of harm to someone. So we decided, hey, can we take some of the images that we already pay for? We pay for images of all of our highways. And can we run it through AI and try to just pinpoint the location of all the signs? Okay, why not? Let's give it a shot. Um, we got approved to pilot it, and we set off running. And this was another one that was really really cool. And we had to figure out a solution that was a little bit out of the box because kind of like with the previous project where we had to figure out a way to get all those documents into one location without clicking or copying and pasting. We used Python. This one, we actually had to use Python again. We stitched them together, but from there, we were able to train the model to look for the signs. So if you work for the Department of Transportation, you probably know what the MUTCD is. It's the Universal Traffic Control Device catalog. Each sign, there's only so many of them. So we had all the images first, and we set out to train a model that could pull them out of images that look like this. So we had this is the data that we paid for. We had this is what all the signs look like. And so if you see this LMR, the left, middle, right, we had to stitch, they come stitched together. We had to split them in 3 parts and analyze each image. Each image had GPS coordinates attached to it, which is what we needed. So we could pull it out of the metadata. So we could prove this asset was where it needed to be. But it was a little bit more difficult because, as I said, the anything text-based, AI is really, really good at it. It's been trained on text for years. It's still figuring out images. And I don't know, I don't know if you've ever tried to have ChatGPT or Copilot create an image, but if you have and you've done it iteratively, you probably have noticed that it's not always the best. I was trying to I'm probably going to upload this on LinkedIn because I was trying to animate or illustrate a children's story that we came up with together, me and my 5-year-old, and it's kind of hilarious the path that we went down and how the images went to being almost close to being just kind of out there. I'll I digress though. So let's move back. Okay, so we need to get the sign images to actual determination of what they were. So this model kind of shows where we were going. The assignable items via text, easy. Assignable items via that were not assignable via text, that is where we found was going to be the most difficult issue. And here you see the higher cost because of the compute power. It had to train the model, and it had to really go through the different images. And sometimes it had to go through all the images to get trained. And we had millions and millions of pictures that it had to get through. So here's an example of what I'm talking about, where the easy ones here are on the left. You can see they all have words. So right out of the gate, the model knew what it was. But some of these without text, it was really confused on. But we were able to feed them through Gemini, and eventually it was picking up on them. Again, if you want to know how much it cost, I can tell you. You can ask me questions afterwards, or send me an email and I can tell you, because it was kind of expensive. But we were able to get to, it only being able to figure out the ones on the left to being able to get all the ones on the right. And it essentially got 99.9% of all of the images that we shoved into it. So we did 65 and 70. We didn't do every single road. This was still considered a pilot because of the cost and that we were, using credits, etc. But again, we used Python, which is great. But if you are in IT, you have people that use Python. It's kind of a standard now. And it was just amazing to see what AI could do. This is kind of the infrastructure that we used. If you're not familiar with the Google Cloud platform, Vertex is the engine. It's the AI, the ML. BigQuery is where we stored items. And somebody was asking me about how do you know if your data is secure and where it's going. Google uses these things called buckets, where you could it's basically like like a OneDrive or something, but you have it stored. You can close it off from the internet, and that's one of the ways they've been able to get FedRAMP and GovRAMP, is to prove that it definitely is not uh, available to any other uh, versions of GCP from any other vendors, et cetera, and it doesn't go to Google itself. Same thing with BigQuery. So we put all the pictures in buckets, and all the data was in BigQuery, and the engine that did everything was Vertex AI. So this was another success. We claim 100% precision because even though it did get one thing wrong, it the sign was actually, it identified the right sign, but it was on a billboard. So it was a construction sign that had that was kind of up in the air, but 100% precision. So this is actually supposed to move on to production if we can afford it and justify the ROI. Because as it stands now, in order to kind of come up with ROI, we're just estimating if we send somebody out to do all the signs, and there's associated costs with that versus how much it costs to train the model, but on signs for another road and then run it again. But this is another excellent use of AI that turned out to be, success for INDOT. And I'm not sure, I don't think I've heard of any other departments of transportation doing that as well. So since well, I guess we're good on time. One of the other items on the agenda was our research programs and pilots. Now, Jamie, did you want me to stop for questions, or did you want to do questions at the end?
That's totally up to you.
Okay. I wasn't sure of the format. Were
Yeah,
there,
either way. We've done both.
okay. We can possibly, if anybody has any questions right now, maybe if they're in the chat, you can tell me what they are, or we can turn people's mics on. Nothing yet? Okay. All right. Well, I'll move on then. So at INDOT, we have a research program that's joint with Purdue University, and some of the money is federally funded, and the rest of the money is Indiana funded. But Purdue, their PhD students will do projects for us. We have meetings. So in 2025, we had meetings on potential programs, and then we've now set an agenda for 2026, and then there'll be kickoff meetings. And so the sign project that we did, that started out as a Purdue pilot. But the other two projects I'm going to talk about here that we're kind of doing are also going to be joint programs as well. So the crash data cleanup and just JTRP in general, and then the work zone safety one is one that if you live in Indiana, you'll recognize this one, and maybe not with good feelings. So the crash location data cleanup is one where we have all this data and we have a great database where people can search to figure out where crashes happen, and it's public facing. It's a Tableau dashboard that's searchable. But if you've ever heard garbage in, garbage out, and your data is only as good as what you put in, etc., that's kind of the issue. So what's the point in having a database with all this data that you can search on if you're not 100% sure it's accurate? And what happens and what causes the problems is that the data that goes in comes from police reports that are generated by police officers sitting in their vehicles, and the location is either set up to use wherever they put in the location or where the police report is submitted from via GPS. And if you can look on this picture over here, so this happened in the middle of an intersection. Usually what happens is a police officer is going to get there, and if the people can drive their cars, they'll get them out of the intersection, and then he'll talk to the people, and he'll sit in his cruiser, and he'll write out the report. So the location could end up saying, oh, it's in this report, it's in this parking lot, the Walmart parking lot, let's say. The GPS could say that. Well, we know it didn't happen in a GPS parking lot. So then you have to look at the notes and figure out where it is. And that's kind of manual in order to fix the location in the data. So we thought, well, there's a lot of information in the notes section And there's a starting point based on the GPS stamp. So maybe we can use AI to come up with fixes for the actual data. So here's a picture of the Tableau dashboard that we use, that anybody can get on the Indiana website and search for items. Now, this is a couple screenshots of what we did when we piloted it. And again, it's crazy what AI can do. In just a few iterations of trying this out, we were able to drop in all of this data. So the data on the left is just a dump of data from the police report. You can see a lot of it isn't even filled out. So it went off of the text down here, the narrative, and was able to put it in this form right here. And we didn't even tell it to put it in, this 1, 2, 3, 4. It did it on its own, and we just kind of ran with it. And it even talks about the reasoning behind why it did what it did, which is great. But it was able to come up with, we did numerous police reports we knew were incorrect, and it was able to find the locations. And it even put in the Google Map link, which we didn't ask it to do, which, you could tell it not to do it, but the fact that it even did that, wonderful. So this is another situation where we had AI, people came to us with an idea and we're like, hey, let's give it a shot. And sure enough, we were able to do it. So this is one that's about to get greenlit as well. Now, and the main reason why some of these haven't been greenlit just yet is because we didn't have a dedicated AI tool to use. And if you're in public sector, I wouldn't be surprised if a lot of you don't have AI studios just yet. I know some public sectors have things like Copilot, et cetera, but they don't have the studio. And so to build repeatable solutions like this, you really do need to have the AI studio, especially if you're using Python, et cetera. And I think it was like 2, 3 weeks ago, we had some funding. We finally got an actual staged environment of GCP that we're paying Google for. So now all of these pilots are going to be turned into actual projects, which is really, really cool. So the Joint Transportation Research Program that I've talked about, it has quite a few different things going on. Now, because we're the Department of Transportation, some of them do have to do with pavement and figuring out pavement and things like that. But here's a few of the ones that I have been a part of that are particularly cool. And we're getting kind of close to time. So I'll go over them relatively quickly. But the connected camera system, let's go back here. So enhanced traffic pattern recognition. This is one that's really cool where you have LiDAR cameras and you have these little boxes. I'm not sure how many people are in departments of transportation that are on here, but they monitor traffic patterns and they store them, but also can tell based on events. It uses these do actually link to the web, and that's why it's a POC, because we haven't gotten approval for anything to go to the web. So this is actually stored on in a box at a intersection at Lafayette, or in West Lafayette, which is where Purdue is. But it can use historical data on events from like basketball games and football games and what the traffic patterns were then, as well as what's happening currently. And it can tell you, the probability of accidents and where they would occur and where bottlenecks would occur. It's really, really cool. The integrated smart work zones, that one is on hold. That was involved putting RFIDs in construction vests and pylons, etc. But it's a POC and it can do exactly what it said it intended to do. And that's another really cool one. The LiDAR-based traffic monitoring system, that's one that monitors intersections and can tell if cars are moving too fast, etc. Based on LiDAR cameras, and it makes the determination using AI. And then connected vehicle data projects. This is interesting, and I'm not going to say disturbing, but I was talking to the head of JTRP from Purdue, and the amount of data that goes into the cloud, seemingly without consent, is kind of crazy. So it's not an INDOT problem, but if you ever bought a brand new vehicle, apparently one of the sheets in there that you sign when you buy your vehicle is you understand that your data is going into the cloud and you don't really care where it goes. So even if you buy a used car, they don't ever turn that off. So some of the connected vehicle data projects that they're working on for 26, there's just millions and millions of rows. And so in GCP, I talked about BigQuery, which is the database. We're putting in, I think, 15 billion rows of records every month. It's crazy because that's just connected vehicle data. And anything from how quickly your vehicle stops, where it stops, how fast it goes on the regular, which can help, obviously, in Department of Transportation to use that data wisely because we can see where everybody's speeding and we can see where everybody's slamming their brakes on, et cetera, because we have that data. So there's a lot of uses for connected vehicle data that we've just scratched the surface so far. Now, this one is one that the work site speed control system is one that if you're in Indiana, people are already kind of annoyed about because it's automated cameras when you're in work site zones. So it uses AI and OCR, as you can imagine, to grab people's license plates that are speeding, in particular work sites. If you're from Indianapolis, you know pretty much every highway, every road has got construction on it. But this is another really cool one. Not, in my opinion, not as cool as the other AI projects I mentioned, but it is another AI project. When I give this uh, presentation to people in Indiana, I always hear the groans of people like, "Oh, you're responsible for that." People do get tickets from it. So the benefits of integrating AI. Did anybody have any questions yet before I move on? Okay. So a lot of the stuff you probably have figured out. The time saving is what a lot of people focus on, and that's true. So the document project was like 80 hours per person, estimated so many people. Um, uh, and the bridge weight limit verification. Oh, I didn't talk about that one. That one was one where they take pictures similar to the sign project of the bridges because we already have pictures of the bridge signs, and it can tell if what the weight limit says on the sign is accurate to what is supposed to be on that bridge. Um, but accuracy is good as long as you train your model appropriately. That is the biggest thing, and that's the thing that I found out right now. You've got to train the model properly. Yeah, the speed at which AI can react, it's pretty crazy how quickly it can do things and detect things that a human being could not do themselves. But the challenges uh, are pretty big right now. So the data quality, putting bad data in, so monitoring the data you put in is probably tantamount to actually just using the AI itself. You got to have good data. Otherwise, the second thing will happen here, which are hallucinations. And I'm not sure if any of you know what hallucinations are. If you're in AI, I'm sure you do. But it's a real thing. And hallucination is when it gives you an answer it really believes to be correct based on the data it was provided, and it's 100% not right. Um, and sometimes you can figure out why that happens, sometimes you can't. I was on a project where I had to come up with, because we knew we were going to implement GCP, I had to take a list of all the software that we had at INDOT and figure out which ones would be good good pieces of software to move into GCP to save some money because if you have things on-prem, you got to pay for support and the on-prem servers could die and all these things. So I used AI to do that and it was great. And I had this list and I told it what to do and the prompt was spot on and it was chugging away. And there was 240 pieces of software, which is a lot. That's another project alone, trying to get that down to 80 from 240. And on line 80, it just was going, it was giving me answers for software that wasn't in the original list. And I wasn't sure why. And it wasn't a huge, it wasn't a huge thing. I was already working on other projects. This was kind of a nice to have doing this list. And I could do it manually myself, but it wasn't one of those things where here we go, we've got these hallucinations, and it's 100% sure that the answer it's giving me is correct, and it wasn't. So the data quality has to be good. Um, and then maintenance, usually with anything software as a service, there isn't a lot that surrounds that requires maintenance, but mainly feeding up, making sure the model is accurate. So maybe one example would be the sign asset management thing, making sure that the signs, like if there's an update to the MUTCD codes that we retrain our model. That would be an example. But another one of our specific challenges too was because everybody is budget strapped was centralized IT. So I'm not 100% sure if you're not, well, so if you're not in public sector, you may not have to deal with this, but at the state, centralized IT supports every department. And so when there's a software implemented, they charge for support. However, in order to save money, one of the good things about, say, like a Salesforce is you don't need centralized IT to support it because there's no infrastructure to really support. There's no on-prem servers, and all of your licenses can be, it's a one-time setup. All of the permissions and licenses can be tied to your user ID, which is your company email, and you can just have, a super user locally. Well, what we found is in the state, no matter what the software is, they still charge you an amount for support, which can be frustrating, especially when you're trying to come up with ROI. When software as a service makes a ton of sense, when say you're paying $10 a user for centralized IT to support one piece of software, and then the software as a service, you feel like you're going to get rid of that $10 because, and you're also saving, $10 because it's cheaper, and then you find out it's really the same cost. That may be just a public sector thing. I'm not sure uh, if private sector still does that. But here's my data quality. Some examples you may have heard about Amazon's recruiting tool, where it was trained on data that was bad. So it was only looking at one gender's uh, resumes. And then same thing with the AI and the Apple credit card fiasco in 2019. Now, this is the early days of AI, so hopefully they got it corrected. But if you get Google, you can find lots of examples of all this stuff. And so the legal assistants that were using generative AI to summarize legal documents, and the stuff that came out was kind of like what came out when I was doing the software list. It just was, it thought it was right, but it was based on who knows what, and it was wrong. Same thing with the Bloomberg terminal integration. Again, you can Google lots of examples of this. So these are huge things you got to look at, and that's why testing your models, not going straight to production, is huge. So we're getting a little late, but ethical challenges, data privacy concerns. When we're looking at different people's, looking at the sign data, things like people's license plates or faces could possibly be in there. The crash data example, I blurred out somebody's actual name, things like that you got, because whatever you throw into your model is going to be in there. It's in there. So you've got to now have to do another step where you tell it to ignore certain things that are already in the model. Or if it's going to generate something or pop something out, you got to tell it to blur it, etc. So then the security challenges are real, because it seems like every day there's a new AI tool, and a lot of them are out of the country. And so you don't know where your data is going. So you really need to read the user agreements. And so I'm our AI product owner, and I was our anytime you had an AI tool you wanted to use that had to go through me for INDOT. Some of these came back once legal looked at them because of the agreements being out of the country. So, and obviously that's not saying everything goes out of the country is bad, but you never know. Ethical decision making, keeping the human in the loop. I talked about that. Definitely got to have a human in the loop, because AI is not perfect. It'll get you 90% there, but you really got to be careful, and you got to make sure it's doing what you want it to do. So I probably talked really quickly, and I hope a lot of that made sense and didn't just sound like a ramble. But there's a lot of cool stuff that we've done at INDOT, and I'm pretty proud of it. So if anybody has any questions, that's the end of my presentation.
All right. Let's see, maybe if you stop sharing, we can just see everybody, and that way if there's some hands that go up. Thanks, Vicky.
Sure. Let me see if I can even figure out how to stop sharing. Okay.
That toolbar floats onto another screen.
There it is.
Yeah. Does anyone, you can just come off mute. We're a small group today. Looks like Jim, you came off mute. Putting you
Yeah.
on now.
Um, so Matthew, you're the product owner of this team that did all these projects. Did I hear that correctly?
Yes, I was.
Okay. So I'm curious, how, what approach did you take? What approach did your team take and you when it came to learning how to use the AI tool and incorporating that into I assume you're doing sprints. I don't know, maybe you're not doing sprints.
I was doing sprints on the document project, but it was one sprint and we had our stand-ups every day and checked. Like the first day we came up with, hey, what are we going to do? Let's get some quick backlog items and then get going. Um, but the other ones we didn't use sprints. A lot of it was just kind of trying to figure out what was we were capable of
Hmm.
and where we wanted to go because we didn't 100% know what we were trying to get to. So it was a little different than say building a piece of software. We know what we needed to do, I guess.
Okay. So following up with that answer, um, did you have some type of milestones or feedback loops? If you're not doing sprints, were there some type of milestones that your teams were working toward, or how did you, I don't want to use the word manage, but I'll just use the word manage. How did you manage that development process? Um,
We did a sprint retrospective for the sign data, the sign asset one. And from there, we came up with some ideas for the next project that we were going to do. We definitely
mhm,
did that. The same thing for the document project. We had a retrospective and talked about things. Mainly for that one, it was communication because we ended up doing it again because I think, as I said, other departments wanted to use it. So we really needed to know what worked, what didn't, kind of standardize it. But some of the other ones were everything was so new, it was kind of just like, hey, let's just go and see what happens.
mhm.
Especially since we had Google credits, so we weren't worried about, getting charged too much for our compute power.
Okay. Okay, that's all I have.
Yeah.
Thanks.
Looks like Karen has a question. She wants to know if any of these technical advancements hit into adaptation issues, and if so, what were they and how did you address them?
What do you mean by adaptation issues? You can talk if you need to.
Yeah, go ahead.
Well, by the people who were working on the projects and also the people who were going to be benefiting, throughout the organization.
Oh, you know, are you talking about things that may not have been well received? Like they didn't want to move to that, like adoption
Kind of all
problem?
of the above. What resistance did you get at any
Okay.
particular level of the project, and as
Okay.
far as design and development, implementation?
So for the document project, I think I kind of mentioned we did it before asking permission to do it. So we got into a little bit of trouble with that one because
Good for
they,
you.
and the person who was the champion, her name is Allison Grand, and she co-wrote the white paper with me. The only reason we were able to accomplish some of this stuff is because we had someone that said, "Hey, let's do it now and then ask, for forgiveness later," which is normally not that's not the norm in the state. But here we are now, and I've got other departments, other state areas that want to ask what we did and how we were able to get it done, and that's kind of it. But it probably freed up, it probably helped other areas because once here in Indiana, we had this group called the Management Performance Hub, and they're kind of a go-between departments and IT. They were the ones that are kind of the gatekeepers and like, hey, you can do this, you can't. Once they quizzed us and grilled us on what we did for the document project, even though it used AI, we did everything right. So it actually helped because it changed how you get approval for projects, AI projects, because it was a really long, lengthy process, and that helped them change the process. And they had instead of having one thing, one acceptance process or submission process, they had two or three because what we were running into sometimes, and I know this is long-winded, is let's say you're using something like Adobe and then all of a sudden it updates and now you've got AI. Technically, we weren't supposed to use it, and they had no way to do that other than saying, hey, you can't use it until it's approved. and that happens all the time, even if it's not AI, because we had software that we were using that wasn't AI, that since AI is cool and it's the buzzword, they would just say this new update has AI, and it was the same software. It just was doing, not machine learning, but like a decision tree, and they would call it AI. So anyway, us doing that and doing it correctly and getting it done right helped MPH change, because they were not on board to change up until that happened. But as far as using AI, everybody wants to use AI. So believe it or not, there hasn't been any adoption issues with any of this stuff. It's more of we want to use it now, but we don't want to wait.
Okay, thank you.
And if you're in public sector, I can't see everybody, but are a lot of people on here in public sector?
No,
If not,
no.
what's that?
I'm not.
Okay. Well, I can get you in contact with some of the Google people that gave us credits, because I know a lot of state governments are Microsoft heavy, and Google's really trying to get themselves in the door, and they were extremely cost effective. And so I guess back to your question earlier, the only people that were pushing back against us was our centralized IT. They were in deep with Microsoft, and they were really hesitant to even allow us to use Google. And like I said, it was mainly because we already had an instance of it with Purdue that we were able to test. But since then, we've gotten centralized IT on board, and since we're paying for it out of our own budget, they've allowed us to roll out Google Cloud Platform to the whole area. Excuse me.
So just curious, their openness to Google was based on just free, what they were able to accomplish.
There's two things, and maybe Microsoft could have done it, but because we had an instance of it already that we could play around with, we were able to get going and try some things out, because IT would not, like, it's now November, and IT has just allowed us to get Google Cloud Platform, and they said they are rolling out Microsoft, and Microsoft hasn't. Copilot hasn't rolled out yet. Just the chat part has, but not the studio. And so in order to get things done, the main reason we use Google is it's the only thing that we had access to. We had all these ideas and we had this need, and so we didn't want to wait 10 months, because it started back in January or February. We didn't want to wait 8 months in order to just try to get a sandbox to try out AI. So after using it for 8 months, now we're like, okay, we want to buy it.
So some of your choices weren't based on it being the best tool or what you thought was the best tool. They were based on, I can get access to this.
That's initially how it was, but kind of as I said, they wanted to roll out Microsoft, so we at least got to try Microsoft as well. So I was part of a pilot program to use Microsoft's version the last 2 months, and it's definitely not as good as Google was. So we lucked out by choosing the right one. And that's another reason why we didn't have to go with Microsoft, and why they allowed us to get GCP, because Copilot would crash a lot. It didn't integrate as well as it was supposed to. You'd switch between web and work, and it would lose all your information. All your prompts and things. It just wasn't that great. So we kind of stumbled into Google, but after using both, we know we made the right decision, and it's cheaper.
Okay. Well, thank you. Those great questions, everyone. Thanks for your engagement. And Matthew, thank you so much for coming today and for joining us. And we really appreciate it. Great topic. So
Thanks for having me.
yeah, thank you. We appreciate it. All right, everyone. We have the recording, and Matthew, if you want to throw your LinkedIn in the chat, maybe.
Oh, sure.
If others want to contact you, I'll have him throw his LinkedIn in the chat.
Yeah.
Stumble strategy. Thanks, Karen. All right, everyone.
Oh,
We'll
come on,
leave that
LinkedIn.
there.
You know how it is. Oh, we're getting close. It must be my internet because I'm
Either
streaming.
that or you can search for them. I don't think there's many.
There it is. All right, here. Let me pop it in the chat.
All right, perfect.
Okay. All right. Thanks, everybody.
All right, thank you. Thanks
Thank you.
again, Matthew. Appreciate it.
Thanks, Jamie.
All right,
Okay.
take care. Bye.